areas without use of integration. You will not be required to do the integration. You don't have to find which function to be integrated, what will be the limit. You can do it direct. The area of OAB, that is on ellipse. Triangle area can be found using determinant method or that shoelace method, some people say, that stairs method. If you take the center here, there will be three equal triangles which are created by joining center to A, B and C. There can be infinitely many such equivalent triangle on auxiliary circle and corresponding to that on ellipse also. Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. In today's session, I will be talking about one very useful thing, that is areas without use of integration. What is this? Actually, I have compiled a few results that if we can remember, then in many questions, including JEE Mains, JEE Advanced also, you will not be required to do the integration. You don't have to find which function to be integrated, what will be the limit. You can do it directly, just like finding the area of rectangle, square, triangle, something like that. Okay. The advantage here is that it will reduce the calculation error possibility and it will also save your time drastically. Okay, so let's see which kind of area I'm talking about. My first area here is related to parabola. Here, there's a famous theorem called as Tudu's theorem, although it is not part of the most of the textbooks and other curriculums, I will say. But this is one very important thing here. Please see, if you are given a parabola that is cut by a chord AB or secant, you can say the area between these two is given by d cube upon 6l. What is d? If you draw perpendicular from A and B to tangent at vertex, so that is actually the projection of this chord over this tangent at vertex. This length is d, and L is the length of latest rectum. In standard parabola, it will be like 4a, like y square is equal to 4ax or x square is equal to 4ay. So that will be 4a. Okay, this can be proved definitely. I will tell you how this is proved, but I will not do it completely because the purpose here is to tell you more such ideas. Suppose you are having this parabola whose equation is x square is equal to 4ay. I have taken upward parabola and it will not matter whether it is upward, downward or any other rotated also. Okay, here I am taking this line to be y is equal to mx plus c. This is x1 here, this is x2 here, let's say, point of intersection of line with parabola. So this x1 and x2 can be found using by solving actually y is equal to mx plus c. If I put it here, it is a quadratic whose root should be x1, x2. So you can find x1, x2, or rather you can use sum of roots, product of roots, difference of roots whenever it is needed. Now this required area here would be integration from x1 to x2. Upper function is mx plus c and the lower function is x square upon a dx. Okay. Now if you do the integration and you start putting the limits, you will be getting like this: x2 square minus x1 square plus c into x2 minus x1 minus 1 upon 12a x2 cube minus x1. Now you can see from every term x2 minus x1 is coming common. In fact, x2 minus x1 is that length d which I talked about in the previous slide. It's the length of projection on the tangent at vertex, which in this case is x-axis. Okay, so if you take x2 minus x1 common from everywhere, so one d is coming common out from it. And then this will be x2 plus x1, this is just c, this will be x1 square plus x2 square plus x1 x2. So using that sum of roots and product of roots, you will be able to find this area is coming out to be d cube upon 24a it would come. Why? Because the formula was d cube upon 6 into length of latest. So this is the result here. I will talk about few more results that are also important in parabola, although you can derive or you can find these areas using Tudu's theorem also, but I will strictly say these are very important to remember. Once you remember, you will never forget it. Okay, please see what it is. Suppose you have to find the area of the parabola with its ordinate and axis. This area I'm talking about. Okay, so this area is actually equal to 2/3 of the rectangle formed by OMAN. Okay, this point is A on the parabola. So draw a perpendicular on x-axis, or axis rather, and on the tangent at vertex. So this rectangle, whatever area of this rectangle is, this area inside this parabola axis and ordinate is 2/3 of the. Okay, if O is origin and this is along x-axis or y-axis. In that case, this would be having area nothing but alpha into beta. So this desired area will become equal to 2/3 of alpha into beta. Okay. Similarly, if we have to look for this area, it is nothing but the remaining part of this rectangle which we counted here. So if it is the remaining part, it has to be 1/3 of the rectangle, isn't it? Okay. Similarly, if I join vertex with A and we are looking for this area, it will be nothing but this 2/3 of the rectangle minus half of the rectangle, because OA is the diagonal. So the area below it would be half, it will be 1/6. Okay, so this is how this is derived. You may remember just 2/3 thing like here, then automatically it will become 1/3 and this will become 1/6. So this is about. Now coming to circle, and then I will extend this thing to ellipse also. I think this is one very trivial thing everybody knows. It is just to complete the things here. Area of the sector AOB is half theta r square. Theta is all angle subtended at the center. If you have to find the area of segment, smaller segment, suppose AB is some chord of the circle and this area we are looking for. So how you will be finding? We will be finding the area of the sector, which as I told you, it was 1/2 theta into r square. And I have to subtract the area of this triangle also, which the best method would be half into side square, side into side into sine of angle between that. So half theta minus sine theta into r square. So this is how this is coming. So whenever you need this, you can use this formula directly. And then suppose you are having two parallel chords like AB and CD. You can use the previous result which I told you, okay, and you take the difference of these two will give you the answer. Okay, so here if suppose AB is subtending theta 2 and CD is subtending theta 1, then the area will become half theta 2 minus theta 1 minus sin theta 2 minus sin theta 1 into r square. It is the case when center is away from these two parallel chords. If your center is lying in between, then again I will recommend that you use that result which I told you here. Which one? This one, theta minus sin theta into r square by 2 to find this area. Although this is very direct, you can remember this result also if you wish, but I still say if there is any confusion, go to the previous result and derive these things. In this case, 2 pi minus theta 2 minus theta 1 plus sin theta 2 plus sin theta 1 into r square. You can check these results also. Okay, so this is related to circle. Now coming to ellipse. Now ellipse, because its equation, x square upon a square plus y square upon b square is equal to 1. The integration, if you are doing it, it becomes the form of integral of a square minus x square. There is a big formula like x upon 2 into root a square minus x square plus a square by 2 into sine inverse x by a. So you have to put the limits. So it is definitely a big calculation. So here what we can do, first of all, we should remember the complete area of the ellipse, that is pi AB. A and B are semi-major and minor axis respectively. But if we have to find some, sector of the ellipse, elliptical sector. So please listen carefully. Always for an ellipse, this sector will have a constant ratio to the sector of its auxiliary circle. Okay, so here suppose B point is A cos theta comma B sin theta, and if I take a corresponding point C on its auxiliary circle, okay, A cos theta comma A sin theta, A cos theta comma A sin theta, then this desired area here and the area of the sector AOC, they will always have a fixed ratio, and that ratio is B upon A. This ratio is B upon A. So this required area would be B upon A times the area of the sector of AOC of the auxiliary circle. Okay, so this becomes half into theta into AB. Okay, but remember this thing, the theta here is not the angle which is seen here by this thing. It is actually the corresponding point on the auxiliary circle, and geometrically this angle would be the theta. So never use this theta as to find the area using this formula. It has to be through auxiliary circle always. Okay. Now similarly, if you are having two radius of the ellipse which are not like one along major axis or minor axis, then also this can be used. In this case also, please see the area of OAB, that is on ellipse, will be having same ratio B upon A with the area of the circle, that is OCD, where C and D are the corresponding points on auxiliary circle. So half theta into AB will be the area once again, but theta in this time will be theta 2 minus theta 1, where theta 1 and theta 2 are the are the angle corresponding to C and D. C and D, you can see from this A and B, the differences. For A it was A cos theta B sin theta. For B it was A cos theta 2 B sin theta 2. For C it would have been A cos theta 1 comma A sin theta 1. Okay. In fact, this that is theta 2 minus theta 1 is actually geometrically this angle only in that diagram. If you go by this angle, but again I am warning you that do not use this angle as theta 2 minus theta 1. It is not. It is simply not. It has to be from the auxiliary circle. Note here theta 2 minus theta 1 should be taken from corresponding positions on auxiliary circle always. Similarly, if you are looking for elliptical segment, suppose AB is a chord of the ellipse and we want this area to be found. Now you take corresponding points on auxiliary circle C and D. So this segment area and this segment area will again be having same ratio. So this will be B upon A times the area of the circle. So if you know the area of circle, you can find the area of this segment for ellipse also. Okay, and for that you need to find this theta 2 minus theta 1, and once again theta 2 theta 1 are on auxiliary circle and not on the ellipse. Please remember this thing. Okay, so these are few things about circle and then ellipse. Let's do few questions to understand this thing which I have discussed here. This question is given here. Area is x comma y such that x square less than y less than maximum of x plus 2 comma 4 minus 3x. Okay, and we have to find the value of k. Actually, we have to find the area, and everything can be found. So here you can see this y is greater than or equal to x square, means it will be upward parabola like this. Okay, and its latest sectum would be 1 because it's x square is equal to y, so latest sectum length is 1. And this line x plus 2, this is my y axis, let's say. X plus 2 line would be having, I think, 2 as the intercept on y axis, slope would be 1, and 4 minus 3x will be having y intercept to be equal to 4, so this will be line something like this. Okay, so these two lines and this parabola will be looking something like this, but they are saying maximum of these two things. So maximum of these two things means I need to take this straight line up to this point, and after this point the other line, that is x plus 2, should be taken. Okay, and this is the parabola here. So basically this yellow color lines, you can see yellow color boundaries are the boundaries are giving you which area to be found. Okay, now we can do the calculation. I will not do it here. I'll just write the points. This point comes out with minus 4 comma 69 here, which is the intersection of this 4 minus 3x line with y is equal to x square. The intersection point of these two lines is actually 1 by 2 comma 5 by 2. Similarly, this point here is actually 2 comma 4. Now, if we have to find this required area, what I can do, I can join this 2 comma 4 with minus 4 comma 16 and find the area of the parabola using Toulouse theorem, and then I'll subtract the area of the triangle. Triangle area can be found using determinant method or that shoelace method, some people say that stairs method. Okay, so both are done directly. Now, if we have to find the area A, it should be first the area of the parabola using Toulouse theorem. So you can see that projection length would be 2 minus 4, so it will be 6. So d cube upon 6 into L. L is 1 here, latest sectum length, and minus the area of the triangle. Area of the triangle we can find using determinant or whatever I have found it. This area is coming out to be, I think, 27 by 2. The area of this triangle is 27 by 2. Okay, now you just solve it and you get the answer. And the final answer comes out to be 45 by 2 for area. And if you're looking for 2K upon 50, it will be 3. Okay. Now please see, if you're not doing this question by this method, how you would be doing? You would be, integrating from -4 to half for this line minus the parabola. Then other line minus the parabola from half to 2. That way you can definitely do it and you can check it whether your answer is coming out to be same or not. But here you can see it saves time. Please understand it. Okay. Next question. So this is one very famous question. If I am not wrong, it's a very old previous year JEE question, maybe 90s. So it says find the area enclosed by parabola and the tangent to it at 2,3 and x-axis. Please see what parabola they are giving us. This parabola is right open parabola whose vertex is 1, 2. So 1, 2. 1, 2. And when y is equal to 0, so x will be 5. So 2, 3, 4, 5. Somewhere here, this parabola should be meeting the x-axis. So this is how your parabola would be formed. Vertex is 1, 2. 1, 2 somewhere here. Now the point 2, 3 would be 2, 3 here. It will be upper. It will be on upper portion of the parabola. This point is 2, 1, 2. So 2, 3 would be here. So this is the tangent that we have to find. And we are looking for this area. Okay, now how to find this area? I think we can find this area of parabola using Toulouse theorem, and we can find the area of the triangle, and it is just by half base into height, because this point to this point will be base, and the y coordinate of this, which is 3, will be the height of this triangle. So you can find it from here. Let me do this calculation also here. For this parabola, if you do the differentiation, its differentiation would be 2 into y minus 2 into dy upon dx is equal to 1. At the point 2, 3, if I put it here, dy upon dx, which is the slope of tangent, y is 3, so it will be 1 upon 2. Okay, so the equation of line, because slope is half, it will be x minus 2y, and if you put that point 2, 3, 2, 3, so I think plus 4 is equal to 0. Okay, now if you put y equal to 0 here, I think this point is minus 4, 0, and this point was 5, 0, that is all I need. This is 2, 3. So area of the triangle would be half into base, that is 9, and height is, I think, 3. So it will be 27 by 2. Okay, now this area can be found using Toulouse theorem, and it will be because this is the tangent at vertex. So if you take the projection, it is nothing but the difference of y coordinates, which is 3 here and 0 here. So 3 cube upon 6 into L. What is the L for this? Again, I think 1. Length of data sector. So we are getting 27. We can write it as 9 upon 2. So the final answer for area would be 27 by 2 minus 9 by 2. How much it is? The final answer given is, I think, 9. 9. I'm also getting. Okay. So you can see how easy it has become if you know this Toulouse theorem thing. Otherwise, you will be doing the integration. Maybe you can do the integration on y-axis, because this is a right function minus left function, that also can be done. Integration with respect to x would be difficult here. Please understand it. Because if you're taking integration from -4 to 5 directly, it will be difficult thing, because parabola will be having two different formulas for upper portion and lower portion, one with plus sign, one with minus sign. So that is not recommended. The next recommended thing would be doing the integration with respect to y. But I think this is the best method, no doubt about it. Okay. Hello? Yeah. Now one more question actually. find maximum area of a triangle inscribed in an given ellipse. Okay, so what is the question? That you are given some ellipse and you have to find the area of a triangle which is maximum possible. Now please see, I told you that for ellipse, any area on it and the corresponding area on the auxiliary circle always be a fixed ratio, that is b by a. B by a times the area on corresponding auxiliary circle. So here we all know this thing already, that for any circle, triangle will have maximum area if it is equilateral triangle. So any equilateral triangle you take on this, circle, and then for these points go to the corresponding points on the ellipse, something like this, something like this. Okay, so these points will give you the maximum possible area of the triangle. Okay, in fact, there can be infinitely many possible equilateral triangle on auxiliary circle and corresponding to that on ellipse also. On ellipse, that area, that triangle will not be equilateral, but area will be maximum if corresponding triangle on the auxiliary circle is equilateral. Okay, if you have to find this area, it should be just b upon a times the area in auxiliary circle. How to find this area of equilateral triangle in any circle? I think very easy. The best method which I found is that if you take the center here, there will be three equal triangles which are created by joining center to A, B, and C. Okay, so it will be 3 times 1 by 2 into two sides which are A, okay, into sine 120. So using this, I think you can get this desired area, and I think this comes out to be 3 root 3 upon 4 into AB. Okay, so very simple method if we are aware of this fact. Otherwise, it will be a big trigonometric question if you are not using this thing. Here I have made one diagram for that only. This ABC I took where C is lying on y-axis, but it may not be necessary. It is just one of the case. There can be infinitely many such equilateral triangle on auxiliary circle and corresponding to that on ellipse also. One more question. Yeah, this is actually PYQ questions from now. This is a question in 2016 and that was supposed to be a difficult question in my opinion. I'll tell you what was the difficulty in this. Here we are given x comma y belongs to r square. Y is greater than or equal to under root mod x plus 3. If we do the squaring, it will become y square greater than or equal to mod x plus 3. Okay, so this is actually depending upon mod opens with plus sign or minus sign, it will be a right opening or left opening. But in original function, y has to be positive. Otherwise, if you take this equation, then y can be negative also. But we have to understand after squaring we are getting parabola, so we have to consider only positive values of y. Okay. Now please see what kind of diagram we will be getting from this. Suppose x plus 3 is positive, then it will be right opening for parabola whose vertex will be at minus 3 comma 0. Okay, if x plus 3 is negative, then it will be left opening parabola whose vertex will again be at minus 3 comma 0. So this is this diagram actually is consisting of these two parabolas, half branch you can say. And also y is greater than or equal to this thing, that means my region should be above these two curves. Means this portion above I need to take also for this thing also. Now this is a straight line, you can see. In this x plus 9 less than or equal to 50 means x should be less than or equal to 6, and this is a straight line. If you solve this line with this equation, let us first solve for the right portion, that is y square is equal to x plus 3, and if I put x is equal to 5y minus 9, 5 by y minus 9 plus 3, so the quadratic would be y square minus 5y plus 6 equal to 0, which gives you y is equal to 2 or 3. Okay, and both 2 and 3 are possible, so this line will actually cut this right portion of the parabola at 2 points, 2 and 3, something like this. Okay, this is the line. Please understand. The difficulty here was the student thought that line will be cutting at just one point, and that is at x is equal to 6. Please understand this thing. When y is equal to 2, when y is equal to 2, what will be the x coordinate? If y is 2, so x will be 1 here. 1 comma 2 here. And if y is 3, 15, so it will be 6 here. Okay. So 6 comma 3. 6 plus 9, 15, yeah. So what people did a mistake is that they considered that this line is going to cut at this point directly. There is no portion below this parabola. An interesting thing is JEE Advanced people, they have made one of the option so that if you do this mistake, you get correct answer and you get wrong, you get 0 or negative marks for this question. Okay, so this thing was important here. Now we can find this point also if we solve y square is equal to minus x minus 3, and if I put x is equal to, it is I think 5y minus 9. 5y minus 9 minus 3. Okay, so it will be y square plus 5y and plus 9 minus 3, so minus 6 is equal to 0. One of the root is, I think, coming out to be y is equal to 1. Yeah, y is equal to 1 is what we will be looking for. The negative root is not required because this will be in the upper branch, this will be in the lower branch, which is not applicable in our question. Okay, so this point is y is equal to 1, and if you put y is equal to 1 here, the value of x would be minus 4. Minus 4 comma 1 is what we are getting here. Now, if we look at the complete thing now, my required area would be above these two branches of parabola, and this y should be less than x plus 9 by 5. So this portion should be below this line. That means this is the area which we should be looking for. This is the area which we should be looking for. Okay. See here, this is not which we are looking for. Please understand, because my area should be so that y lies below this. Y is less than x plus 9 by 5, so it should lie below the straight line. But in this case, it is not the case. Similarly, my y should be above parabola also. So this is not which we will be looking for. We are only looking for this thing. Okay, now how to find this? Please understand it. I think we can find the area of this trapezium directly. Okay, this is a trapezium, simple. How to find the area of trapezium? Half into sum of two parallel sides, so 2 plus 1, 3 into distance between two parallel sides, that is 1 minus minus 4, so I think 5. So this will be 15 by 1. Okay. Out of this, I will subtract this one and I will subtract this one, which can be found using 2/3 thing, because this is the vertex, this is the axis. So from this to this, you can see minus 3 to 1. So this is 4 into 2, 8. So this will be 16 by 3 area. How I found it? The rectangle, if you form here, it will be this thing. So minus 3 to 1, one side would be 4 and one side would be 2. So 4 into 2, 8. 8 into 2 by 3, 16 by 3. Similarly, this area would be minus 3 to minus 4, so minus 1 only, and height is 1. So area of rectangle is 1, so it will be 2 by 3 actually. 2 by 3 plus 16 by 3 is how much? 18 by 3, that is 6. So we have to subtract 6 from it. So 15 by 2 minus 6 is 3. So this is the area of this question. You can see it is done. Now, if you are not doing this question with this method, how you will be doing? Again, same thing, minus 4 to minus 3, you have to do the integration of this function. And what is this function? Please understand. It is y equal to under root of minus x minus 3. Okay, this is, if you have to write it in terms of y from in terms of x, it will be like this. Okay, and similarly on the right hand side, it would be y is equal to under root of x plus 3. It will be simple, but here you can see minus sign are coming, which is also easy, not difficult, but yes, there will be calculation, and this can be, there can be some calculation error because of such expression, and this is, I think, much easier than this. Now come to one more question. That question is from 2019. Here they have given one hyperbola, rectangular hyperbola, and one is y less than or equal to x square. So let me make this diagram. Y equal to x square here, and this y is greater than 1. So there will be upper line, lower line, lower boundary is equal to 1, and y equal to x square. And this is xy less than or equal to 8, which is rectangular hyperbola, something like this. Okay, so this is the area which we are looking for. I have taken this question deliberately because what I felt here, that especially in this question, use of anything like to-do's theorem or two-third, one-third thing is not that useful. Although you can use it, please see here, this point comes out to be 1, 1. This point comes out to be 2, 4. And this point is coming out to be 8, 1. Now this is rectangular hyperbola, this is parabola, and that's a straight line. Now, if you want to find the area of this thing, it will be from 1 to 2. That is, parabola minus 1. That is x square minus 1. This upper boundary is parabola, and at this point the lower boundary is y is equal to 1. And after this, it is 2 to 8. 2 to 8, and upper boundary is, I think, 8 upon x minus 8. So with the help of this integration, you can get the answer. I think it's not difficult thing. For this portion, I will say you could have done it by to-do's theorem also. How? Please see. If we have to look for this area, it can be the area of this triangle minus this area of the parabola that can be found using to-do's theorem. Area of this complete triangle, because this is 2, 4, this will get 2, 1. So base is 1, height is 3. So area of triangle would be 3 by 2. 1 into 3 by 2. And this area of this portion, this small portion which is bounded between this line and the parabola, can be found using to-do's theorem. That would be the projection on tangent at vertex would be, I think, 2 minus 1. So 1 here, d cube upon 6l. For this l is, I think, again 1 number. So this is. So I think if I take the LCM, 9 minus 1, 8 by 6, so 4 by 3. Let me see if I'm able to correct or not. Yeah, 4 by 3. You can see that using this integration also you will get the same thing. Definitely in this question, this will be faster. So it is up to you that if you feel that integration is becoming easier, then definitely use this thing. But this is useful in many more situations where integration gives you a longer path than this. Okay, coming to next question. This is from 2022. Please see what this question is. Here we are given one parabolic x square plus 5 by 12 upward parabola, and there is one function gx. It is given by 1 minus 4 mod x upon 3 for mod x less than or equal to 3 by 4. Otherwise, it is 0. Okay, so this graph of parabola would be like this, whose vertex will be at x coordinate 0, y coordinate 5 by 12. Okay, and this graph of gx, you can see if I put x is equal to 0, this becomes, I think, 2. Okay, and this will be something like this. For y equal to 0, I think x will be equal to 3 by 4 here. 3 by 4 here and minus 3 by 4. Okay, and this point of intersection also can be found with the help of solving a quadratic x square plus 5 by 12 with 2 times 1 minus 4x upon 3. Okay, so let me write these values which I am getting. This point of intersection here is coming out to be, I think, x coordinate is 1 by 2 and the y coordinate is, this is 2 by 3. Okay, so what area we are looking for? Let us first figure out that thing. It is saying for mod x less than or equal to 3 by 4, y is between 0 to minimum of fx comma gx. So this parabola is fx and this downward mod, you can say, is your gx. So who is minimum at which place? I think from minus 3 by 4 to this is, I think, minus 1 by 2. This is minimum. parabola is above. After that, this parabola is minimum up to this point, and then again this is minimum. So this is how we are getting minimum thing, and between y equal to 0. So this is the area which we are looking for. This complete area we are looking for. Now we can use symmetry and we can say area on the right side of y-axis, that is in the first quadrant, and the second quadrant will be same. So we will first find this area, we will multiply by 2. Now how to find this, please see. If I make a line, tangent line at this point to this parabola, okay, this will be 1/3. Remember, 1/3 of that rectangle. Which rectangle I am talking about? Here this is 0 comma 5 by 12. Okay, so this one side is 1 by 2, 0 to 1 by 2, and this is 2 by 3 minus 5 by 12. 2 by 3 I can write 8 by 12, so 3 by 12, so 1 by 4 actually. 4, that is 1 by 8. Area of this rectangle is 1 by 8. From that we can write it directly. This would be 1 upon 24. 1 upon 24. Let me check my calculation also. Yeah, correct. This rectangle here is having one side is 1 by 2 and height is 5 by 12. So it will be 5 upon 2. For this, I think it is just a triangle only, whose base is 3 by 4 minus 2 by 4. So 1 by 4 here, and 1 by 4 into 2 by 3. 1 by 4 into 2 by 3. So it will be into half also. So 1 by 12. Yeah, 1 by 12. So the desired area here, desired area would be 2 times the sum of 1 by 12, 24, 5 by 24, that is 6 by 24. So 1 by 4 here plus 1 by 12. 1 by 24 plus 5 by 24 is 6 by 24. So 1 by 4 plus 1 by 12. So if I take the LCM, so this is 3 plus 1, 4 upon 12. So 1 upon 3, 2 upon 3. Area, the entire area is coming out of 2 by 3. They are asking for 9 alpha. So 9 alpha would be 6. 9 would be 6. Okay, so you can see here also it was much easier with the help of the 2/3 thing, 1/3 thing. Otherwise, I think in this question, what you will be doing, you will be doing integration from 0 to 1 by 2. That is not difficult at all. And then 1 by 2 to 3 by 4, obviously you will be doing by triangle, not by integration, but triangle. Or you can do by integration also, it's your choice. But what I'm saying, if you're comfortable with these methods, I think you reduces the chances of calculation error. Okay, so that is question 22. Now I'm having one more question, I think from 2024. Here again they have given two parabolas. One is this one, y square is less than or equal to 4x. That is right opening parabola. Okay, with vertex at with tangent at vertex as y-axis. Okay, and the other parabola is left opening parabola whose vertex would be at I think 6 comma 0. If you take 2 comma, yeah, 6 comma 0. So it will be something like this. This is 6 comma 0. This is 0 comma 0 here. Okay, and there is one straight line also. Okay, if you do the calculation, you will find out that point of intersection here is 2 comma 2 root 2. In fact, this 2 comma 2 root 2 lies on this straight line also. This straight line, if you put y equal to 0, the x is coming out to be 5. So the straight line is something like this. Okay, so this parabola, other parabola, and the straight line, these are the graph I have drawn here. And x greater than or equal to 0, y greater than or equal to 0. Let us see what area are we supposed to find. So they are saying y square is less than 4x. So any point lying on the axis, say a comma 0, 3 comma 0, something like that, will be satisfying it. So that means for this parabola, inside region of the parabola is required. Similarly for this one, if you put let's say 0 comma 0, I think 0 comma 0 is satisfying it. That means for this parabola also, the region lying inside it will be considered. For this straight line, okay, you can see 0 comma 0 is satisfying it. So for this straight line, the region on this side where origin is lying will be considered. So combining everything, I think we are looking for this area. Okay, because x greater than or equal to 0, y greater than or equal to 0 is also to be considered. So this is the area which we are looking for. So you can see there's no use of this left opening parabola here. We need this area in which first part I can find by 2/3 by doing 2/3 of the rectangle for this parabola, and for this I will be doing area of the triangle, and we will get the answer. Okay, so this first area A1, let us say, yeah, A1, if I say this, do this, so because vertex is at 0, 0, this point is 2 comma 2 root 2, so it would be 2 into 2, 4 root 2 into 2/3, so 8 root 2 upon 3 would be this A1. And to find A2, half base into height, this is 5 comma 0 here, this is 2, so 5 minus 2, 3, so 1 by 2 into 3, and into height is 2 root 2. So if you cancel this 2 here, you get 3 root 2. So the complete area would be sum of these two. So 3 into 3, 9 plus 8, 17 root 2 upon 17 root 2 upon 3. And we are looking for area is alpha root 2, then we have to find the alpha. So just remove this root 2 and you get the value of alpha to be 7.